So the next speaker is Giulio Sandini. He's founding director of the Italian Institute of Technology, where in 2006 he established the Department of Robotics, Brain and Cognitive Sciences. And I agree with him a lot in that robotics needs the humanities also. And we organized some forums about this. So please.
Thank you very much, Carmen. Thank you. It's very nice. Very nice to be here. You know, one of the advantages of getting old is that the number of friends increases. You know, and I found many here, which I haven't seen for years, and it's very nice. So and then again, when you're getting old, you of course you start looking back. You know where you were at the beginning, where you are now, and you pretend to have some idea of how to go forward. You know, and that is more or less what I'll try to talk about today. So this neuroscience and engineering of artificial system is basically my life story, you know, since I did my master thesis working on the control strategies of a high-end coordination system, and my PhD working on a neuroscience lab doing recording from the visual cortex and perceptual studies. So this is the environment I was working on when I started my career as a researcher, and at that time, you know, it was were the years of computational vision. The focus of research was on edge detection and you know, these sort of peripheral features. I was working on you know, this space variant sensor because I was interested in understanding why our retina is so strange and why the visual cortex receives such a distorted image and it is able. Well, the answer is simple, you know. It saves a huge amount of energy. That's the trick. In those years, though, the other you know, aspect which I think was very strongly influenced my research career was this, you know, David Marr's computational approach to vision. David Marr and Tommy Poggio, you know, they were leading a group at MIT working on parallel between vision in artificial and biological systems. But you know, at that time, it was mostly the research on vision was mostly on model-based, you know, the shape-from approach. So the goal was of vision was to extract the shape of object. You know, the visual brain was driven by a geometrical engine somehow. You know, the main research. Then what happened? Then you know, there was this active vision revolution, and you know, some of the friends I've seen here, Regina. And Yanis, Dana is not with us anymore, but you know, I think that, you know, I still remember the first talk that I heard from Regina Baici many years ago in Pisa, and that was a stamp which remained on my skin since now. But you know, also robotics. You know, in those years, you know, there was this what I call the Rodney Brooks trilogy. You know, and the Hopper, which somehow showed that, you know, there are other ways of trying to understand intelligence and put it into context. You know, and it was exactly in those years that, you know, this first ICRA. In Atlanta was, by the way, it was, as you can see, it was run by the IEEE Computer Society. Russ was not there anymore. But, you know, in parallel to that, as far as my, you know, evolution of my career was concerned, you know, I had the very first European project, you know, in those years. And it was, you see, I was very young at that time, you know, and one of my best friends is David Vernon. He was also very young at that time. And we did this, and the title is still what I'm doing, image and movement understanding. You know, so after 40 years somehow. But anyway, there have been advances. After that, there was a period where we invested a lot of time in building robots. And I met some other key people, and Giorgio Metta was going to talk about his ideas tomorrow, but also from the neuroscience, Luciano Fadiga working on mirror neurons, and Klaas van Ossen working on cognitive development. Those years were really very important to me. We had many projects, but also in the field of robotics, the word cognition started to raise. This is just the number of published papers in IEEE, which contain in the title both the word robot and cognition. So there was a big increase around 2007, 2016. So that's the idea of action, execution, and understanding. The next step was the RobotCub project, which is still the project I liked most, all the projects I coordinated. And if you can read the names of the people there, most of them are here sitting here today, and some of them are not here. But basically, that was the idea of building a robot to study cognition. That was to study cognitive development, in fact, not only cognition, but cognitive development. And this was, the dream of my, life career. And the other lucky moment for me was IIT. I had the chance to write the first scientific program of IIT, and I tried to put there as much as possible this link between natural and artificial systems with the idea of starting from science to develop technology and going back to society somehow. So that I will not go through the whole steps of my career, of course, but what I want to summarize it is with the fact that during these years, I've been able to develop groups of people working in the same areas and with the same let's say, long-term goal that I was fond of. And this is my major results of my career. So basically, we put human and robot in the loop, studying human-robot interaction and so on and so forth. But how did we do since, this 1984? Well, certainly I can say I have not delivered the system that I promised. It's research. Otherwise, but we have learned a lot, maybe more on neuroscience than on robotics. On the other hand, also through workshops like the one mentioned here, we have realized that there is an utility in building artificial systems to understand humans and vice versa. But that's the important part. So now we have, bodies continue to evolve, but we have fantastic bodies. I'm just putting some videos here just to show some of them. There are others which are maybe even more surprising. But this fantastic body still don't know what they are doing, and prospection is missing. It's mostly, it's not only action perception loop, but it's just a little bit more than that. Why I think that exploration prediction may be a much more interesting group. So, and that the reason is that while we were working on action execution, we underestimated the role of action imagination. And imagination, as Italo Calvino put it, is a basic human faculty, the power to bring vision into focus with your eyes closed. You can close your eyes and imagine to do all actions possible and even all actions impossible, in your brain. So what is, again, this is another definition of Italo Calvino of imagination, is a tongue twister, but I think it's very nice. So this is one side. Italo Calvino was a writer to me, it was a big also an important scientist, but is mainly known for. If you have time, read these 6 memos for the next millennium that he wrote a few just before dying, unfortunately. On the other side, if you look at neuroscience, you find statements like, Marc Jeanneret saying that real movements are consequences of internal simulations. And there is a whole theory, or that the brain is used to predict the future, like Alain Berthoz put it many years ago. So the problem, in fact, the limit is not to learn how to use a tool or how to reach a goal, but how to find different ways of reaching the same goal and different tools to put them into use. So it's the imagination kind of things, and so my idea now is that we should focus on the artificial, more on the artificial cognitive architectures, what I call the imagination machine, which again, the imagination machine is a kind of electronic machine that keeps track of all possible combination and selects those that are more suited to simplify things or to make things better. So, and there are, the machinery of the mind. The mind as a hardware also is not only the hardware of the body. The mind is also embodied. And if you look at nature, the structure of the brain of animals is not very different. There is a structure behind which is the same. Of course, then, the cortex is bigger in human and so on and so forth, but the structure remains the same. So we need converging studies to address the issue of function and structure and the mind of embodied systems. We need to study how to harmonize the different time scales. We are adaptable systems, but we went through evolution, we went through gestational period, we went to development. So all these periods use different tools and act in different ways. Maybe first the structure and then the function, but that's what. So which tools? How you divide online things from offline things, structure before, the structure and function again. So I think this the idea of a cognitive architecture as a shared reference, shared reference between, for example, computation and that. Our brain associates, does not compute. You have to go to school to learn how to add numbers, but you don't have to go to school to associate the taste of an apple and the look of an apple. This is something which comes. RGPUs, successful and sustainable solutions to implement intelligent embodied system. I personally don't think so. I think we should look for the NVIDIA of cognition somehow. And to summarize, I think that should be guiding the convergence of different approaches in our research. Function and structure, I mentioned already, data and models, the different time scales of adaptation, evolution. Maybe deep learning is good to learn the structure which we have for evolution, in which case it's fine if it is very expensive in terms of energy consumption, because you do it once. You don't do it, for all. And then, this study of human and artificial systems. And, my last slide in most of my talk now is this one. So we, roboticians, are really interested in building systems, put everything together. And when I say everything, it's really everything. It's not just, a part of a problem, it's the whole problem. But I think we need to collaborate and to work with others, not only in words, but in real joint projects, It is a bidirectional advantage of both communities. And with this, I close just by making a little bit of advertisement to this technical committee of RAS on cognitive robotics, where people interested in these aspects, organize events and meet together. And with this, I thank you very much.
It is time for quick questions. It's hard from here to see.
Thanks. Okay.
I don't see.
We'll have time. There is a discussion in the afternoon about intelligence, where if you are interested in these topics and also other topics related to robotics intelligence, you should attend. Not because I'm there, but all the others are very, very good. Thanks.
And also because Giulio is there. So.
Thanks.